That was awesome.
Thanks,
I'm glad I'm one of the neats and the scruffs.
You are a neat set. Well, folks, I don't know the folks know, but I certainly know you have a degree in mathematics.
I did get a master's degree in computer science, and people don't know I was a doctoral student, and I studied machine learning when the NEETs were kind of still in charge, and my models were very mathematically beautiful, and I have always struggled with neural networks because mathematically they're just not like perfect.
Anybody I know that has a strong mathematical background, they loathe the lack of a proof. They just don't believe it unless there's a proof. And neural nets are remarkably resistant to proofs.
It's a problem, and people don't know. There is an entire theory around all machine learning models except for the neural networks. Like there's something called PAC learning, which stands for probably approximately correct, where you can tell how many data points you need for a particular model to give you the probability that it's the accurate percentage is something, right? So, and you can literally mathematically define that. And there's something called DC dimension. There's an entire and this is Chernovenskis and Vapnik came up with this stuff in the 90s. And so when I studied machine learning, it was like, okay, there are some pretty cool things. Like I love SVMs because they're mathematical beauty. And I've talked to Turing Award winners about deep learning, and their answers tend to be quite squishy.
Yeah. And it's not normal, right? You think about in the arc of people that I was describing there, guys like Turing, and I didn't mention von Neumann and so forth, but long before the hardware could do the computations, they had built the models for computation, right? The Turing complete computational model was an important part of knowing you'd built a valid computer. And so the fact that we're struggling with mathematical proofs around these neural net models, it's deeply concerning for the validity of the process.
And it's very squishy. Like, here's an example. Simple mathematical example. Everyone has heard of a parabola. It's a big U.
Yeah.
If I were to ask you to mathematically give me the minimum value of that function, it's easy to do.
Yes, of course.
Derivative, set it equal to 0, it tells you where it is.
It's the bottom of the U.
Yeah, and those are called convex functions because they basically have a single answer. The thing about neural networks is that they are non-convex, complex shapes in multiple dimensions. And so there's no way to know, number one, are you in the right bottom U? Because you might just be in a hill or a little valley if there's a deeper valley. And then the other question that I've always had is, like, how do you empirically, it's only empirically, but you have to empirically figure out how to structure these models. And I asked a Turing Award winner, how do you know? And he's like, well, you kind of just do what people have done before and you go from there. And I was like, you're like a world-renowned expert in deep learning.
And you're saying the answer is close enough?
The answer is like,
well, I mentioned Arthur C. Clarke early on in 2001: A Space Odyssey. He's also the fellow who said first, any sufficiently advanced technology is indistinguishable from magic. And here we are. There's now literally magic as a service.
It almost sounds like,
and that's what worries me
to me.
Because anthropomorphization of AI is probably the worst thing we can do for ethics.
Well, without a doubt. And we give this technology credibility that we don't have. Well, the machine said, so it must be true. Right? We take the errors we have made in our past, stored as data, build models around it to amplify those errors.
Yeah.
Amen. And I was in a panel once, and I think I got invited to the wrong panel. It was like in Texas for like educators, right? And like there was like other company salespeople, and I was like, I think I'm at the wrong meeting. But they were talking about AI in such a way that I was like, hey, friends.
But I'm going to stay.
Sorry to bring this up here.
Yeah.
But we're humans. You draw a face on a rock with a Sharpie, and our immediate reaction is, oh, it's happy. No, it's a rock.
It's a rock.
And people get mad at me. They're like, well, you're calling AI a rock? Yes, I am.
Yeah.
It's a rock that has data burned into it.
It's a very fancy rock, but it is still fundamentally, it's a tool. It's a tool we made.
Yeah, and then everyone all of a sudden were like, oh, and then the sales dudes from the other companies were like, well, I don't know what to say after this. How do we sell this?
And therein lies the problem. Like we've taken a lot of technologies that already existed and bundled them under AI because it was hip and it's profitable, right? You know, you the joke of the beverage company that just added AI to the name of their beverage and sold more. It's like, you know, it's just a naming strategy. And so, you know, there's a downside to that, which is that it does tend to distort things. But I also appreciate that as soon as it's a viable product in any way, you give it a new name. It gets pulled out.
That is true, and that was interesting. That little that chart that you did, it was interesting because I was like, oh yeah, once you give it a name and you strip like the mystique out of it, you can make a pretty good living off of it.
And this is where I make salespeople upset and say, we use artificial intelligence. It's my experience is anything labeled artificial intelligence is stuff that doesn't work. When it does work, it gets a new name.
And that's why I guess I am an AI cloud advocate, because I really don't work.
Haven't worked for years, Seth. We've done stuff together now for more than a decade.
That's right. And I haven't worked a day in my life.
I know you have way too much fun. We can see it on your face.
That's right. That's right. Well, I'm sorry I'm talking, Richard. We get into these discussions sometimes, and it's like, this is unfair, Willem, because we've known each other so long. I mean, I can tease him endlessly, really. That's right. There is endless things to tease me about.
It's true.
And I have to say, in this case, since my sound is really bad today, I'm really happy that you're having this conversation, actually. And I'm learning a lot from this one, especially. And it's totally fine. So I've got a question. We talked about these neat guys and scruffy guys. Do you see any crossovers happening from the scruffy guys to the neat guys? And I have to say, in this case, since my sound is really bad today, I'm really happy that you're having this conversation, actually.
Well,
and I'm learning a lot from this.
Are you asking does Seth swing both ways? Yeah, I think he does.
I do. And like, if I were to go back to school and finish, because I was a college dropout. If I were to go back to school, I would literally spend the next 7 or 8 years trying to come up with formal methods or verification methods for neural networks. Maybe, for example, pack learning works in some way, shape, or form with deep learning. Maybe there is a structural model beyond deep learning that we can use, because in the end, it's all dot products and functions and like vector subtraction. I mean, that's all it really is.
I had read some of the papers coming out of the explainable AI effort from DARPA that very much they were talking about that particular problem of we're trying to understand why neural nets are coming to the decisions that they are, where they find their probabilities, and they were using decision trees to explore the neural net. Like, it's just interesting to me that those two disciplines feed against each other ultimately, or could feed against each other ultimately, to help them both be better.
Here's the kicker. People don't know this, but when it outputs probabilities, they're not actually probabilities. They just put a function at the end that forces them all to sum to 1.
Yeah. It's just a number between 0 and 1. Never 0 and never 1.
Yeah, and it's crazy that people are like, oh, here's the probabilities. And like, if you talk to a pure statistician, they'll literally just be like, that's it. They'll throw their ball on the floor and leave the house, right? Because there was a cool meme I saw. Like, there must have been a bar fight somewhere and people were throwing chairs at each other, and the statistician said, looks like somebody just said machine learning is just applied statistics, and everyone's throwing chairs at each other. It's a find that I laughed for years.
Just a bunch of if statements?
Yeah.
So would you say?
Yeah, I think so. I mean, we're in the end, we're ultimately doing the engineering of applying these things and getting useful results. And every time we do that, I think we help to some degree to validate things. There's plenty of bad models too, right? I do feel like our profession is being improved by the challenges of dealing with data at this scale, right? That we have the ethical conversation has always been there. We're now surfacing it in a much higher level, and it is part of this is the anthropomorphization effect. When we threw the word intelligence in this, and we are handing these tools agency they ultimately should not have, it's made us look back at ourselves and say, these are not the data's biases, these are our biases that are manifest in data. And now we're using tools to amplify them. And I've used this line in the boardrooms, like computers are only amplifiers. They can amplify your intelligence or they can amplify your stupidity. Which would you like?
Yeah, and I would add that even in my limited look at Lyman Schaap, they're basically looking at a model post facto, after it's been built. Like for me, I would like to know more about it pre facto. Is that a term? Right? Like I'd love to know like what is the power in this thing. For example, like I said, there is something in pack learning called VC dimension, where like a certain machine learning model can shatter a space. It's called a shattering, and you use that how many spaces it can shatter to do some approximations. That's a formal method of looking at models, but you can't do that with deep learning right now because there's no way to know like what the VC dimension of a particular deep learning model is, because it's so variable. And that's like those are all post facto. Let's look at a model after it was built, as opposed to what is it that we're trying to build and how expressive is it?
You know, I wonder if it's almost a nutritional content problem, right? It's like you don't eat the food and then decide whether it was good for you or not. You kind of read the label, right? We've created a construct that says this is the contents of these things, this is the nutritional value. And I'm starting to feel more and more about that, about data. Like, I don't want to read this data until I know its basic qualities. I need its nutritional content. Because then ultimately these models would be manifestations of the sources of information. And so if we qualify the sources of information, we should have the potential for better models.
My advisor in grad school, Hal Dalmay, you can look him up, he co-authored a paper called Data Sheets, which in theory is supposed to solve this problem. In essence, what you do is you have a data set that is accompanied with a thing called a data sheet that says, this is what we were thinking when we made this data. This is what's in the data. This is where we got it from. This is the segment of people that it came from, right? And so that's an interesting idea, but notice that's an interesting like human approach to it. But again, there's no mathematical way to show.
The way you described it sound like intent rather than content. Yeah. Right? What's actually in the box.
And those are called data sheets, and you can look that up. There's also something called model cards, which are similar things, but they describe a particular model. And this is the research that's going on right now. But to me, like you hit the scruffs versus the neats thing very well. Like it doesn't hit me in the right spot. You know, it's like I feel like it's still too fuzzy. Right.
Well, and both of them were consuming data largely from similar sources. So we still have this overarching problem. And every data scientist I've ever spoken to says the same thing. It's like you spend 80% of the time validating the data. In some ways, the model's kind of the easy part. Do you know what you have? Do you know the nutritional content of this data set?
Yeah, and that's the rub. Most people don't. And then because they don't, whatever bias is burned into the data. I'll give you a simple example. And this is, I can find you sources later on, but it turns out that in the United States, we over-police a certain segment of our population. So if a police precinct were to say to me, Seth, I want you to build an AI model to tell us where we should go find crime. Well, if I use their data, what do you think it's going to tell them to do or where to go? Right?
Wherever they went before for crime.
Yeah, and it turns out that if they over-index on a certain subpopulation of American citizens, the model will say, yep, that's where we go to find crime, because it turns out that if you're looking for crime, you're probably going to find it. And if you are looking in a specific place every time, then all of a sudden there's a double problem, right? Yeah. Now you have computers saying that these are where the crimes happen. And that's just a simple example.
But then, and it gives it this credibility. It's like, it came from the computer, it must be correct.
So, Marian, you're working with AI on a daily basis. How do you, for example, combat bias in your datasets?
Yeah, that's a good question. I think we started with that. Like, are you are you doing your sampling part right? And again, are you looking with the right sheet? I mean, it's hard. And it's I agree with Seth. I mean, you're training your model based on historic facts. So yeah, if you're looking for crime, you will find it, right? I mean, you find it where it were. So and as said before, I think we humans are already biased. So how can you get the bias out of yourself? And well, I think that's also a challenge in itself.
The data sheet concept is great in the sense that at least you're writing down your bias or what you believe
and
your
your
bias
intent.
is.
I think that's also nice.
Yeah. And because you're never going to eliminate bias. The best you can do is label it. And so the idea that we would deliberately label, this is what we were thinking, this is what our approach, that also tells you all the things they weren't doing. So when you're going to look at that data, possibly for a different purpose, at least you know this was not the intent of this data. So, tread carefully.
Yeah, and then now you mentioned also, I think the intent of the data, that's also, let's say, a methodological problem, that you should use your data where you had the intent for. So you cannot just cross-use it without thinking. I mean,
yeah. That's what I think the data sheet serves. It's like, are you to the purpose of the data from the original intent, or are you cross-purpose to it? And so some additional steps need to be taken.
Yeah.
Overall, I think it's fascinating that we've all of a sudden, we're now to the point where we have some pretty sophisticated models, and now we're stopping to think, hey, maybe we should be smarter about how these things are used and why and when and where.
But that's also pretty normal in human civilization. It's only when something reaches a certain point that we should have some rules, right? I mean, the car came before the driver's license. And well, it's only until we had a certain number of cars, it's like traffic lights. That's an idea, right? Standardization of controls, good idea. Like all of those things emerge with the expansion of something. So I do think we've hit a critical point where we have so much data, where we now press against people's privacy and attention all of the time. And so those are now valued things, precious things, and things that need to be protected.
So for both of you, what are the traffic lights and the driver's licenses for machine learning or AI models? What do you think those should look like? What should they be? And we'll start with you, Mariam, and then we'll go over to you, Richard.
Wow, that's a hard question.
It is.
Again, an answer would be that depends. It depends on the algorithm. It depends on the problem you're solving. So based on the algorithm, you would have, I would say, different rules and different controls or stopping lights. I don't know. Maybe Richard, you can hop in, but.
Well, we've had a barrier to entry right now in complexity, right? Only certain people could be successful with this, that it took certain levels of skill. And that level is starting to diminish, is part of the reason that it's surfacing so thoroughly. What we're ending up with is a gatekeeper concept right now. And you're seeing the pressure on organizations like Microsoft and IBM and Google and Facebook and so forth, those that are largely serving as gatekeepers to the access to this data and these models, to say, take some responsibility on that. And largely, when you look at the partnership of AI, it is those organizations saying, we're going to pay attention to how these things are used and how they're being built. I don't know that it's a good solution, but it is, the current gatekeeper are the cloud providers.
Honestly, like just a simple, how sometimes in California, I lived in California for a number of years, and everything according to the state of California may cause cancer, and there's like a label on it, like
on everything.
This is known to the state of California to cause cancer, and you're like, okay, like just a label that says this decision that the computer is making is influenced by automatic models. Like just that label alone is helpful, right? Just disclosing the fact that you're using automatic methods to make decisions I mean, that label helps a lot because then you're like, oh, well, why did it reject me? And then you can ask other questions, right? I mean, that's just to me like a simple, like tiny stop sign or maybe a speed bump. What are your thoughts on that?
Yeah.
It's the argument in favor of against the computer says, right? It's to say, did you read the label? The label says the computer is only amplifying our own data sets.
Marian, your thoughts?
Yeah, I fully agree because, I mean, even if you take just a simple decision tree, I mean, they're normally very successful, right? But if they're wrong, you can be really wrong. And it's not without a risk. And let's not talk about neural networks, which are way harder to explain. But I see in practice a lot of people that are using, let's say, any alteration on a decision tree, not knowing that they can be wrong. Right, and then the computer says no, but maybe it should be yes. So, yeah, there is a risk. It's a probability, right? I think we have to make clear to people that it's not a yes or no, even if we convert it to yes or no. But we're talking about probabilities.
Richard, and I like the way you put it though. Like adding a disclaimer in really small print is not really a good idea either. I guess I'm just trying to, in my head, figure out what's the license look like, what's the stop sign, what's the stoplights, you know.
Well, I don't want to fight you on that because what I want is no one to be accepting of the response, well, the computer says.
Yes.
Right? Because that's a terrible answer and it should be immediately challenged. I kind of want a little business card that says computers are often wrong. Right. It's just you want to press back against that because they are only ultimately tools that we manifest in the first place.
Cool.
But, you know, our industry is still not a profession, the computing industry, right? We don't have a professional certification. We don't have a group that is ultimately responsible for when its members make mistakes. You know, it's the difference between a software engineer and an electrical engineer or a civil engineer or a doctor or a lawyer, that they're always backed by a group that certifies them and takes responsibility for them, right?
Yeah,
and we've largely been isolated from that.
Early on, I worked at a place that I was the software guy there at a place that served actual civil engineers. Mm-hmm. And I remember one time one of their engineers came in and I was like, oh yeah, I'm a software engineer. He's like, are you? Where did you get your certification from? Where's your license? And I was like, oh. And I obviously I was a young guy still in college then, and I took offense to that. But many years later, I came to the realization that if a bridge breaks and someone gets hurt, there is someone that's accountable.
Yes.
Not only the person who built it, but the state organization that certified it.
Yeah, and the authority and the certifying body, you know, that's the nature of it. And you understand, software, through the end user license agreement, has obviated that responsibility, and for a good reason. It allowed for rapid innovation, right? And you know, we didn't start out with rules for buildings. We just got to a point in sophistication of buildings where falling down had serious consequences, like we should have rules. We are now reaching that point in software. Like there's a question of when do we become a profession? In exchange for decelerating innovation to increase reliability, right? That's the trade we're going to make. The aerospace engineering field still innovates slowly, carefully, because the consequences of being wrong are serious. Software is running the world. These models can shape cultures. We may need to be taking more responsibility for that. And that means changing that rule, exchanging rate of innovation for safety.
And that's an interesting thought process. I mean, is it something we should be doing in AI as well?
Well, I think AI has brought it to the light, right? We're seeing the ultimate manifestation of computing so far, right? There are more manifestations coming. When you start seeing the potential of quantum computing around its changes to the way we'll approach chemistry and different physics models and so forth, that also may be a new class of concern. As we get better at this, as the same way that when the car got faster, the rules became more important. the potential of computing is growing, the rules are becoming more important.
Yeah, I mean, there's certain systems that literally could be like a bridge falling down effectively.
Sure. Right? You think about the efforts we're going to well, you know, our water supplies have technology in them now, right? They're not just pumps and valves, there are computers there. There are computers on every one of our power plants. You know, I'm doing these shows over in RunAs land and .NET Rocks land, talking to folks that are talking about how to SCADA systems get integrated onto the internet and the security consequences that represents. You know, the reality is that an awful lot of our civilization depends on an awful lot of compute that needs to work. And so we are in a transitory period now. I suspect we are the generation that will see us become a profession.
Interesting. And like, when you say that, do you mean like in the next 20 years kind of thing?
Yeah.
The next 5 years? Okay.
I mean, it's hard to predict exactly how quickly, and there's a bunch of different models of how to go about this, and that's a whole other show. But I think that artificial intelligence is just this mechanism now that's showing the power of compute, and some of it unfairly, right? We get into the anthropomorphic things, the Terminators, all that silliness. But it's also useful for the public's fear to say, how are we licensing this? How are we controlling this? It's always actually been a concern. It's just becoming more acute.
Interesting. Marian, as you build stuff, because clearly you build stuff. I'm a demoware person, and I have been for many years. Do you think about these kinds of things as you build stuff with you and your colleagues?
Yes. As mentioned before, maybe just in a very simple form, but to write down everything you make a decision upon. So somebody else can check that with you, can go through it. Also for yourself, I mean, as you develop as a person, you can look back and say, hey, I made this decision, and contributing to bias, basically. So yes, I am aware of it, and I try to minimize it to at least write down my decision, so somebody else at least can see what my intent was. And also, I normally put a disclaimer in my code, like that my intention for a model, because again, if you build a model to, for example, find out which student needs some help, right? You can revert it and say, hey, I'm going to exclude this student. So by including my intent in the code, it's like, yeah, this is the intention of the model, so please use it rightfully. I don't know, we don't have specific rules yet for that. I think I completely agree with Richard. We don't have the licenses, we don't have the controls, but at least I think we have to be, we have to maybe make them and try to make them, and maybe future generations will build upon that. But you have to be aware of, as a developer, I think, you mentioned it, Richard, I think you always have to take your responsibility. How far that goes, I mean, I don't know, because if somebody takes my models and implement it in a way and abusing it, that's hard. I mean, but in theory, you can do a lot of damage. You can do a lot of good, but the same way you can damage a lot. So not only to protect, let's say as a driver, you also put your seatbelt, right? So you want to protect yourself too. But also at least to make sure what your intent was and the decisions you made.
So before I go to Willem, one last question, because I know I've been hogging you all. Let's start with you, Marian. What's the future of AI? And then we'll go to you, Richard, on that.
Well, what I hope, I mean, I don't know what the future is because I'm not a visionary, but I hope people will see it as a tool and not forget that they're human. So yeah, it's great technology, so you can do a lot of things, but please don't forget that you're a human being and you can use technology to do better things. But again, don't just listen to a computer.
Yeah, Richard. I can't argue with anything you say there, Miriam. These are just tools, and we've created a new set of tools that are empowering people to do more. Absolutely.
Yeah. Cool.
Y'all are the best. Thank you so much.
Okay, we're back. Thank you very much, all of you, for joining us. Thank you, Richard, for the awesome session and the panel discussion afterwards. There's a lot more stuff to talk about, I'm sure. But we're out of time. With that, I would like to announce the winner of the $50 gift card for Amazon. M.B. Vandenberg, you're going to get a message from us because you had an awesome tweet. There's no doubt about that. We will make sure that we retweet that and make sure that it's going on my wall, I think, that it's that good. So thank you very much, everyone, for joining us. Next week, we are back on Thursday again. Same time, same place. Hopefully with a better internet connection and better microphones and everything. And then we're going to talk about computer vision. We've got awesome people joining us. So we've got someone from OpenCV, no less the CEO of OpenCV, Satya Malik, who's going to talk to us about their new AI innovations. Actually, a camera that can run deep learning models. So that's pretty cool, I think. And we have Elizabeth from Cisco, who's going to talk about micro interactions and what that means for building AI models in computer vision. It all sounds very, very cool. So we'll have lots more demos to show, a lot more stuff to go through. I mean, thank you very much. Have a nice evening or morning or afternoon or wherever you are. Seth, do you have any final words for us? Any wisdom that you want to share with us?
Yeah. Life is awesome. Go forth and make cool things.
Cool. Thanks. Have a nice day.